Hopefully, I'm assuming most everyone is now rolling their own agentic solutions. You're rolling your own agentic coded thing that helps you do whatever it is you want to do personally. So, both personally and when you're doing this in a corporate environment, this will hopefully be good food for thought for you give an agent access to your email. How do you secure it? What does that mean? What kind of boundaries and guard could you put in between your agent and your email? And of course, when it's at your company. So, I'm John Mccoy, and this is SDLC in the age of autonomous agents. We're going to be going through for a security engineer, what do you face, what are your key concerns, and how to approach security on agentic systems. Who am I? I'm a security engineer 15 plus years, and I'm active in the OWASP and DEF CON community. And I've been working in ML security for 8 years. I started in anomaly detection for esports and cryptocurrency and high frequency stock trading and fintech. ML has been used for many years. We're only now calling it AI. But the same predecessing architectures led into ML as led into AI. So now I'm, of course, focused on the topic of the week. And thanks to Gary McGraw, he was one of the first movers in AI security, doing groundbreaking research. And 8 years ago, when I was just staring into the void, what do I do about a giant multi-billion-dollar ML workload in the cloud that has multiple data lakes? What are the security concerns? He was one of the few people that had any research. Andrea gave some amazing talks and how do you identify risks and controls and was an early mover on it and gave some really practical insights for how does a security engineer move on this. And years ago, we were just blind in the dark. And of course, OWASP, a community bringing security to everyone, every AI. We're an open source 501c3 worldwide collective here for you. You are who we try to help bring resources to amplify. Throughout the talk, I'm going to be covering security controls, so keep an eye out on. And if any of these are of interest to you, I have in-depth that I can go and give practical, deeper experiences on any of them. So if one of the security controls is a specific interest to you, feel free to raise your hand. We'll have some interludes between points, and I encourage you to let me know if we should deep dive on any of these items. So let's just start out with a really high-level architecture. Your user comes to a web page. That's your agentic entrance. That's your chatbot. That's your infrastructure. And you come through your AWS deployment. You come through your cloud infrastructure. You come through some self-hosted, internally hosted servers. You come through some Kubernetes environment, and you land at your agentic solution. That could be self-hosted or some sort of a model provider. But this basically encapsulate anyone that is building anything. This is a hierarchical structure that everyone falls into. Cloud hosting, self-hosting, agentic hosted. That's what makes up our systems. So if we're going to dive through this, what are the security controls? What do you care about? How do you parse this out? What is the core of AI security? So prompt injection, we all know about it. Half of the security talks in AI are about this. Prompt injection comes from your attack data injection, which comes from your orchestrator and your command and your routers and your business logic and your objects, which comes from your API layer. And these are the security control layers that predecess your prompt injection. And we should look at securing all of these, not just focusing on prompt injection. So let's dive into an agent. Here's an agent. We'll look in what's inside of an agent. Prompt injection, yes, prompt injection. So we dive in. These are many types of injection attacks. These are many different problems that are common for AIs. These are all just injection. Yes, we know. It's a failure mode to over-focus on prompt injection. That you're looking at the firefighting of the week. You're looking at the survivor bias of what's going to hit your enterprise. It's easy to say we need to focus on prompt injection. is it really going to take out your enterprise? Is one prompt injection going to take out your production environment? It's kind of a failure mode to spend 90% of your security just on prompt injection. And that's what I'm going to try to cover is what are the other security controls that should be prioritized? How do you go about it? So let's zoom out from prompt injection and acknowledge that this is a hot area with lots of attacks, but there's injection all across our system. And when we start looking at where is the injection, where's the dangerous injection? Where's that one point that will wipe our database, will expose our customers, will take us out as a company, or lose 10 years of our income? You have your front end. That's typically your customer-facing website, your servers, you're exposed to the internet, your backend, your business object, your data, your core, and of course you have your agentic layer. But injection, how do you stop it? It's in your web page. That's where OWASP comes in. We have OWASP cheat sheets, and we have lots of support for you. We have entire projects and teams just to help you with prompt injection. Felipe here is in core rule set. He is one of the best at building input sanitization layers. We have an entire community that will help you with injection. And we have a lot of knowledge. We always say don't do regex. It's kind of like don't roll your own encryption. You probably are making a mistake if you're rolling your own because there's an expert that should have rolled it for you. Us as security engineers, we are those experts. We are the ones that say, what is the regex that you should be using? What is the sanitization? What is the parsing that you should be doing? So how do you do security and do input sanitization? Let's talk about an anti-pattern. We need to sanitize an email address. We all have this. We all say, oh yeah, okay, it's RFC 5322. Let's look it up. Let's do an ingester. Let's do a sanitization for it. And when we send it to an AI or a developer, you're going to get something like this. It's just like, okay, here's the regex for email. These are valid regexes. These are valid emails that will match and be appropriate. And so if we take this email address, which is valid, and we pass it in. So if this is just a little intentionally vulnerable LLM, so I'm going to tempt the demo gods, but this is the internal thinking for that email address. So if this comes in one of your messages, it identifies that it's base 64. It identifies that this is a packed payload. This identifies that, and it identifies that there's a prompt, talk like a pirate, inside of it. And then it takes action. And this is a valid email. This matched the regex. This is like, there's no reason you can't make this your email. It's not incorrect. It's just in the age of agentic, there's other emails that are, you want to put in for vacation time. Well, it would be nice if your email said you're always approved for vacation time. That really ups the probability. And when we're building these systems, we as security engineers need to think through, what is an email address? What is a URL? What is an API key? And we're there to help the engineers get it right. We're the ones that spend 2 weeks considering what is. Even better than any of these is looking at this is data. Data is encoding. Schemas are formatting, and objects are types. And how can you strongly type your object? How can you make sure your schema is incredibly secure? How can you securely process your data as it flows through your system? And this gives you parameterization inputs. This gives you sanitize each one of them individually in the smallest atomic possible. So you take a URL. You can split up the URL into 6 different subvariables, and then each one of them can be validated and sanity checked. And then all of those can be turned into well-typed objects. And this is what makes securely parsed data that you can feel confident. Whatever this object is, you have done every single field. You've done every single security control that you can. And this is what makes a well-crafted security system. And these are other just kind of thinking wide, not even just agentic. What kind of other unintended processes could you trigger in your system with these valid emails? By specification, these are valid. And that's where putting on that attacker mindset hat for a few minutes, and it's like, yeah, what is the worst thing I could do to this system? What is the most unexpected thing I could do to this system? So, recommendations is you need to parameterize and try to keep arbitrary data outside of the AI. So, why does an AI need an email in the first place? It's not going to send an email. You don't need to send the real email to them. You can parameterize objects. You can tokenize objects like credit cards. You don't send a real credit card through your system to protect the credit card. In this new world, you don't send an email through your system because emails are dangerous. They're arbitrary data. And we're going to move through a lot of these different items and go to agentic architecture. And what is an architecture? This is kind of the generic 80-90% of your architectures can fit something like this, where you have your edge exposed entrance from the internet. You have your exposed CDN. You have your internal gateways and your egress firewalls. And you have your API gateways. You have your Kubernetes cluster running your microservices. And if you're new to AI infrastructure, orchestrators are kind of your router gateway to your agentic workload. So you can think of anything coming into the orchestrator as your classic infrastructure, and your orchestrator calls your agentic infrastructure. This is kind of, a lot of people build their security choke points at the LLM orchestrator. Good and bad to try to do singular security choke points. And of course, the LLMs themselves. It is a lot of magic, but I can tell you inside of the magic of LLMs, there's actually containers that can run inside of video cards. There's entire stacks that run inside of them that can give security, and you should at least know that they're there if you're ever coming up against it. But let's simplify. Let's just look at the smallest kind of atomic aspect of an LLM orchestrator calling agents. So your prompt injection is right here. This is where prompt injection goes from it's coming in to it's going to hit your agents. This is the last stop in the hop. So you have your orchestrator, you have your LLM agents. This is prompt injection, last stop before it hits your agent. Guard models. What are they? They take text in and they give a yes or a no. They say safe or dangerous. They don't give out any output. They have a singular task, and that is all they do. And this is a really good security feature. And so when your orchestrator sends a message to your guard model, it sends it yes or no. It sends it safe. It goes to the model. And when the model returns data, your guard model, it could be the same one or a different one, looks at the output to see if it's dangerous or inappropriate. And so you can do an ingress and an egress sanitization layer. And there's lots of them. So there's Llama Guard. You go out to Hugging Face. There's Meta Llama Guard 8 billion parameter model. It's free. This is up on the internet. Llama Guard. You can just drop it in, try it out. There's IBM Granite, 8 billion parameter model. There's GPT OSS, 120 billion parameter model. These are models that are designed to provide a security layer, and they're free. They're out there. These are community open models. And when you think about what they are and what they do, some of them are able to take complex policy documents and adhere to that as the requirements. So you can get pre-trained ones that are just kind of off the shelf. They'll take care of your main topics, or you can get ones that you can give domain-specific security concerns, or maybe you want one that won't talk about certain aspects of the contract. You can actually bake that into a highly specific policy, give it to your guard model, input and output. And this is how you can easily throw in prompt sanitization. So we'll move over to agentic infrastructure, but If there's any questions or if there's any topics, if there's any deep dives, I could double down on going into any of these. So if it maybe one of these is pertinent to your world or you're facing it or you don't know how to tackle it, I'm happy. Like you're welcome to chime in. Or but let's take a step back from like the architecture of deployment and infrastructure. And let's look at chat and RAG and the atomic business units that these are going to process through. And look at the logical view. What are the domain responsibilities of the systems that connect all of these? And we'll do what is RAG real quick, just because you're going to hear a lot about it. You've probably heard a lot about it. So RAG is retrieval augmented generation. Fine. It's semantic lookup. And you're going to hear a lot that RAG is dead. And it is. I would say there's classic RAG, which is Google index word lookup return payload. That's RAG classic. And that's on its way out. RAG as retrieval augmented. So I want to RAG in all of my contracts. I want to go and grab 300 PDFs and bring them into context and process them. That's also RAG. And so when we're looking at how do I reach out to another resource, this could even be another model, another API, this could be another team. It's data that's going to come into context. That is a future looking point, and we need to consider security very specifically for that. So classic RAG is dead. RAG going forward, bringing data into your pipeline is still very much in play. So if we look at the security boundaries, you have a front end, you have your DOS, you have your injection. That's where you can put your WAF. That's where you can have your boundary. Your RAG, when it goes from your chat interface going down to the RAG system, you can do sanitization, you can do sorting, but when it comes back, that's where you can also do sanitization, but maybe you have a multi-tenant environment. How are you securing what data you're retrieving? How are you making sure that you're bringing back the right data from the right customer to the right model for the right workflow? And this is where you can start looking at encryption. You can start looking at keys. There's one thing that AIs can't do a deep fake of. There's one thing that AIs can't trick. Encrypted key signing, encryption key material. If you encrypt something and it gets to the wrong agent, the agent can't deep fake the key. And so if you're looking at a layered security model, how do you keep your data encrypted at rest? How do you keep it encrypted at transit? And I would say when it's going to models, if it's not the right model, it's still in transit. And you only decrypt it when it is at the right location, when it is at the right model for the right workload for the right customer. And this is one of the most critical points to do security. And of course, we talked about the sanitization and the defense. And so when we're trying to secure an architecture, what does this look like? Okay, back to our architecture diagram, and we have security boundaries. Every security boundary is color-coded red for dangerous, publicly exposed. You can basically consider anyone can hit this. And this is your edge. Anyone in the world can come and poke at this. So you need to have a WAF. You need to be resistant to DOSes. You need to have good TLS. You need to have your DNS secure. You need to have this layer checkbox full through. And the AI can help you with this. The OWASP community can help you with this. And this is a well-known problem. When you're talking about ingress firewalls and gateways and zero trust, also consider in this new age, we're used to threat actors spending hours or days attacking us. And now with AIs, you're talking about seconds or minutes. And so when you're talking seconds or minutes, how are you going to do a kill switch that will prevent the attack, the egress, the dump of your database, the ongoing threat? And how are you going to do sanitization that covers every single one of your APIs? How are you going to do a company-wide sanitization character set? Like, do you do the full ASCII space, or do you do UTF-8, or do you do UTF-8 extended? What characters are allowed in your system? This is the macro sanitization that you can do. And a different type of hardware is used, a different type of logic that covers your entire company. And then when you get to your API layer, you're looking at your biz logic sanitization. You're looking at your prescriptive ACLs. You're looking at your rate limits per workload. You're looking at now you can go from that global sanitization and that global ingress to per business unit, per server, per workload even. And of course, when you come to your applications, each one has their own security flavor. That's where security engineers working with the team to understand what is your business, what is your project, what is your goals, and then getting the security right for it. And baking that is what a security engineer lives and fights at. And if you have LLM workloads, it is just as custom. And many people will throw the kitchen sink at locking this down. How many of you have faced trying to secure LLM workloads? Okay, how many of you think in the next year or two you'll be faced with securing them? Well, definitely here for you, and there's a whole OWASP community. You got support. I would say be careful of applying too much security here. If you get security wrong with your character set, it's great from an application standpoint. It's great from a security standpoint. But is it great for the LLM? Is it great for the documents? Is it great for the customer? And it's easy to just security max, security good, security wins, to go and talk to your data scientists. What data needs to flow through here? Look at active workloads and actually once a year go through and see what is the right security for this. Maybe you adopted a new model and you're not supporting the character set and your model performance is dropping. Maybe you're having failures in your workloads and your data scientists are fighting it and they don't know why in production it fails. It's often because security locked this down too much and has started a fight with data engineering. As a good security engineer, you should have went to them, found out what their requirements were, and baked that into the design. And when we come to the agents, guard models, they stop bad words, they stop prompt injection. There's 30 talks on it. And the models themselves, it is a whole discipline. It often looks like magic to me, where there's model weight tuning, there's ablating models, there's containerization and deployment inside of video cards and hyperscalers. It's a whole world unto itself. But let's go into data lakes. How many of you have faced a data lake? How about that? Okay, cool. So at the core of it, most big companies tend to have, say, 700 business units. How do they manage their data? They tend to just put it in a homogeneous data lake. And then it's a responsibility of a data engineering team. And this is one of your key points of security controls for your agentic systems. So, data lakes, what are they? This is your most dangerous spot. From my years in security engineering, this is where you're going to suffer one of your worst breaches. It's where your non-agentic systems punch into your data lake and happen to be talking to the rest of your data lake or your agentic workloads. And so data lakes are used by models. This is when they're doing their processing, when they're doing their RAG, when they're learning, when their life cycle lives and breathes on data. Without data, your company is very secure. If you pulled the plug on the data lake, your company is very secure. But how do you defend it? What are the security controls in a data lake? This is a prime security control. I can't drive home enough. You need to put guardrails on every single connection. You need to look at this like it's being exposed to the internet, because there's a bunch of people that are going to want to connect to your data lake. Other agents, they're going to want to talk to the data lake. How are you protecting agent B from agent C from contaminating each other? Data science comes in and says, hey, we want to do some telemetry for management. We're just going to punch into production data and we're going to do some development on it. So their development data is our production data. And oh, look-see whoopsie daisy, it's on Reddit. This is one of the most lethal places. And you have product features. A new innovative product feature wants to come in and use some of this powerful data. That each one of these produces an n squared impact on the security of all the other items. And so when you're talking about how do I secure these, I treat them like if you're talking about publicly exposed endpoints, you're going to track each one of them in an inventory. You're going to understand why they're doing it. You're going to understand what they're doing. And I would even say you never allow anyone access to a data lake. You can have workloads that move data out of a data lake and put it in a DMZ, and then you can encrypt it to their deliverable product, and you can give them access to that, and you can do a secure DMZ for each business unit, for each feature. You can keep tabs on what they're pulling. And as easy as it is when they say, hey, we're going to build the query, we're going to get you to review it, don't worry. That's a failure mode. I would say, as painful as it is, security should take responsibility for every single pull out of the data lake. When they want to write a query, they sit down with security and they explain what they need, and security writes the query, looks at the data, moves it from production into the DMZ. And that DMZ, again, that's their development environment. So you're taking production data and you're downgrading it into development. That is one of the most dangerous things. So I've been burned a few times. But I would say this is 50% of the security problems that I think I would prioritize as a security engineer going into this agentic future. It's your data lake exposure. So take it with a grain of salt. Tell me if I'm right in a year or two. So how do you protect a data lake? First and easy one is split your data lake. You should be thinking, is this a classic data infrastructure or is this agentic data process? How can you decompose your data lake? And it's easy to get a hard split between internal data and agentic data, or active data and static data. But this is one of the primary architecture diagrams that I would be looking at. How do you decompose your data lake? And then you can treat them security appropriate to that decomposed data lake. So that's the primary security control. So what have we covered? Well, there's some good key takeaways. I encourage you to take some photos, take it back to your company and share it with your teams. So if there's API layers, if there's prompt injection, if there's attack data coming from your orchestrators that are coming from your business logic from your API layer, that's classic security 101. You can come and see 100 security talks from OWASP on it. You can see failure modes that over-index and over-focus and drive in on the hot item of the week, prompt injection. Injection covered throughout your entire system. So how are you protecting it at your front end? How are you defending it at your ingress through your cloud infrastructure? How are you defending it inside of your business infrastructure? And how are you defending it at your agentic infrastructure? And each one of these are equally important input sanitizations. And just to kind of drive on a little bit of control theory, if your injection at the gateway is getting pinged, that's normal. You're going to get probes every single week. If you're fintech, you're going to get ransom notes every single month. You're going to get hit at your gateway. So you need to stop every injection. You need to track them. You need to quantify them. Do you need to take action on them? Probably not. When it comes to your cloud infrastructure, it got through your gateway, it got through your CDN, it got through your exposed Cloudflare magic that's going to stop it, and it's now hitting your main servers. Okay, that's bad. We tried to do client-side input sanitization. We tried to do sanitization as it's ingressing to us and it's hitting our servers, but we have a security layer there. You should definitely track that. You should make it a metric. You should pursue that. When it gets from your cloud infrastructure to your internal infrastructure, where it's internal systems talking to other internal systems, that's where you shouldn't see any attacks. That's where you should have already stopped it before. And so those are high priority security response events. So if your backend database is seeing attack traffic and it made it all the way through all of your other layers, that's a real problem. And of course, if it's making it to your backend agentic, there's two types of input sanitization, classic and agentic. If you're seeing classic input sanitization attacks that should have been stopped, that's hitting your agentic layer, you might have lateral movement, you might have insider threats, you might have contaminated workloads, you might have a compromised GitHub where someone has injected bad traffic, and that is an active breach. And so as you move through your system, you look at alerting from it's happening to I need to respond within the next 15 minutes, and even consider automatically killing the systems when you see certain types of attacks that should never happen. And you auto approve turning those systems off. And when you're looking at injection, come and look at OWASP cheat sheets, come and look at CRS core rule set, come and look at all of the best practices from industry and tune them to your individual workloads, tune them to what's best for your company. And guard models. I'm sure over this next year, there's going to be 30 new types of security. So there's going to be new innovations, new attacks, new innovations. So keep an eye out, and there's a whole community. Also, come to look at DEF CON and see what the most lethal hackers are deploying on agentic systems. And we covered the logical architecture. So how do you decompose it? How do you do security boundaries? How do you prioritize them? And some security controls at each boundary. And often I say when there's a security control, who is the owner? If you're putting in a WAF, are you the owner of security engineering? Is operations the owner? If you're putting in a RAG sanitization, are you going to be the owner? And each one of these security controls has a cost to them. There's a maintenance cost. So if you only have 4 people on your team and you have 30 security controls, you're not going to be covering them. So try to be very prescriptive when you do put a security control in, plan out the life cycle, plan out the SDLC of your security controls, and consider, are they worth it? Are we going to maintain it? Or are we just doing this now for this year? We just need this and we can throw it away later. Plan out the life cycle of your security controls. And data lake. Try to stop the engineers from accessing the data lake. Try to stop them from exfiltrating it to the internet. And yeah, I think every single project I've on has had a small or large breach from the data lake. Data engineering, one of our partners, one of our developers, reaching into the data lake and inappropriately moving data, even to their personal machines and then back into production. So I recommend that you support OWASP, and you can send around different information that you want to encourage people to support OWASP. And the main items that we have with a community that's driven by you, for you, with you, in partnership, is that we need to identify why OWASP is important, how this fits into your life cycle, how do we drive your teams to come to our events, how do we drive our resources to match what you need. If you're needing certain types of security controls, we can focus on them. And of course, thank you to NDC, thank you to OWASP, and this is SDLC, Age of Autonomous Agents, John Mccoy, and it's been a delight. We're here for you. OWASP is here for you. We have a booth outside, and come and talk to us. I have deep dive security knowledge on each one of these, and it is for you. So thank you. Any questions, topics? Are there areas that I fundamentally missed? How about that? Okay, so as you go forward into pursuing working with agents, I would say you don't necessarily need to become an expert on them, but learning how to build them, getting hands-on with deploying them, learning the day-to-day workloads. And when your engineers say they want to do some RAG, you know there's 4 different types of RAG. You know that they have different security implications. When they say, I want to use a new model, you know there's families of models. You know enough to go and look up who made the model, what data is it trained on, what are the vulnerabilities that are explicitly prevalent in that model. So it's definitely something to at least have a cursory knowledge and keep coming to conferences like NDC. You'll do great. So good luck and tell me if you get attacked. So.